Welcome back. Announcements first, just to be clear. Number one, your midterm exam next week. I am going to give you more information in our next lecture, but it's an online exam. The idea is that you're going to use Canvas, multiple choice questions, open questions during the lecture time. Next week, Wednesday, your midterm. Now, some people ask me about the final. Right now, the goal for the final is also during the lecture time in our last lecture, that is April the 21. So that could be the midterm and the final. Next week, the midterm and the final, April 21. So you can put both in your agenda. Good. There are some announcements that was posted by Canvas telling you that your exams are in December, November, or something like that. Hopefully everyone understands that that is not for you. So March and April. Moving forward, topics. We reviewed Observer. Please, class diagram, source code from the previous week, review, and every question that you could have, send us an email. The Observer for sure is in your exam. Moreover, the source code of the Observer is part of the open questions in your exam. You're going to be asked to do programming and in particular do programming of patterns. So that could be Observer or Decorator or both. We're going to cover Decorator today. So we talk about Observer, one pattern in the behavioral category. The behavioral category, you have an object and possible behaviors, action services that object need to do. We review Observer, one object that need information from another, and therefore is observing the other. We review several examples. Today, I want to move to the next category, structural patterns. Patterns about how to connect objects, how to put objects together in a program. Option number one, Decorator. There is a pattern in which the philosophy is we have an object and that object can have decorations. Other objects that alone are not important, but these objects together with the original one, they create something relevant. We're going to review examples. Decoration. I am going to show you, to start, the following example. Imagine that we have an object, this one. We can create that object with a class. And we want to decorate that object. Decorate that object. Yeah, we want to put that one inside of this one. We have another class. I have these two classes, and I can create an object from this category and an object from this category. And what I want to do is decorate the ball with the box, one inside of the other. Moreover, following the same idea, what if I would like to decorate also the box, inserting the box in another box? And I can continue, right? So I have one object that is the original one, the ball. I cannot put anything inside of that one. That is the core, the original. And then I have these decorators, these objects in my example, the box, that I can use to cover the original one, but also to cover another decorator. Decorators, boxes, can decorate other decorators or can decorate original objects. This example with the boxes. Did you know something in Java that behave in this way? Anything that you have done before using Java that have a behavior like the one that you described? Obviously, not with boxes and not with balls, but with something else. Classes that are like this, one inside of another, and that one can go more and more and more and more and more. Well, be careful here, because encapsulation is a little bit different. Encapsulation is the idea that, for instance, this ball is encapsulating variables like color or size or other things, the attributes and the methods that define the behavior of the ball. Or this class box is encapsulating the variables that maybe define the sizes of the box. Encapsulation is more what happened with a class that is covering the attributes and the methods. We are going to use attributes here, so somehow it's related with encapsulation, but is something else. Do you remember what do you do when I asked you to do graphical user interfaces in Java? Do you remember that in Java, you do something like those three lines are familiar? Is something that you have done before? And hopefully it's yes, you have done this before. What you do in Java, when you work with graphical user interfaces, you add these guys, the widgets, inside of a panel. In my example here, I am adding one, but something that you know is you can create more. I am not using here the layouts, those things that you use to organize the elements in a grid or south, north, east, west. That is another story, the printing. But something that you do is you can add widgets inside of panels. The widgets, these ones, or labels or other things, are like the example that I showed you with the ball. And the panel, this place in which you put the widgets, is like the box that I showed you before. Now, can we put a panel inside of a panel? Can we do something like another panel? And in that other panel, just add the previous one. And you know that the answer is yes. You do this. This is something that works when you do graphical user interfaces in Java. And in fact, doing something like this, you can create these two elements that are inside of this panel, and you can put that panel inside of another one, and you can put that another one inside of another one. And by the way, you can put more than one inside of one. That is kind of the idea of here. You can put more than one ball inside of the box, or you can have a box with maybe two boxes inside or more. That is the concept of decoration. Every single time that you create a graphical user interface, you're following the decorator pattern. Obviously, it's just one example, just like the listeners that are an example of the observer. We can use exactly the same for other problems, but just to give you an example of how these work. One object connected with another one, and that another one received the name of the decorator of the first one. But then decorators can decorate decorators, like panels can be inside of panels. And at the end, the widgets are inside of another one of them. The solution for this, I'm reading the chat. Yes, this looks like composition aggregation. Yes. Do you remember that basically when we talk about patterns, we are talking about this level of abstraction, but at the end, this is just one name, one word that describe a combination of the relationship that we reviewed before. The observer, one word, and the meaning of observer was this inheritance, realization plus associations, bidirectional. For the decorator, it's going to be the same. The concept, the idea, with the boxes and the balls, or with the panels and the widgets, you get the idea. Now, the implementation is going to include aggregation in particular. I am going to show you the class diagram. As usual, every single pattern is one idea, and that idea, the equivalent in a class diagram, and the class diagram obviously move down to the source code. What is the source code to achieve this, or the previous one? First, the class diagram. The class diagram for the decorator pattern is something like this. Two important things. Number one, we need polymorphic behavior. We're going to need polymorphism. Why? Because if we want to be able to include inside of a box another box, or in this example, the ball, or if we want to include inside of a panel another panel or a widget, what we need is that the panel or the widget belong to the same family, or my box and my ball belong to the same family. What we need is a common parent for these two, and having a common parent to these two childs make them polymorphic. I can use one or the other. Any of them replace the other. So you will notice inheritance here. Second, if what I want to do is to be able to add one object inside of another, the relationship that I have there include diamonds, include either, as you mentioned, composition or aggregation. Do I want to have a panel that is empty inside? Do I want to have panels with nothing inside? For the Java graphical user interface, the answer is yes. I want to allow panels that are empty. And if I want to allow panels that are empty, I am going to use diamonds, but not the black one, because the black one do not allow me to have null values. I am going to use a diamond, white, which basically means that I can have something or not. I am using the diamond for the class that is going to be the representation of the box. When I put this diamond white, I am okay with the box being empty. Two classes, in my example, the ball and the box, they have a common parent. And the signature for this pattern is this class, the one that represents the box or the panel, inherit from component. Therefore, is a component, but also have a component. At this moment, hopefully you can imagine the source code of the class decorator. Hopefully you can imagine in this class what is going to happen with those two relationships, inheritance and the aggregation. Can we agree that this class is going to extend and what is this? The diam, a variable. Something like that is the source code for this class decorator or box if you want. It's a class that is a child of component and also have a global variable component. What is going to happen is something like the following. I can create an object component. I am going to use the parent. And I can create a component one using the parent. And that one can be equal to a new. And I am going to use this, assuming that this is my class. I can create another object component. And that one can be, and I am going to use this as a name. Can we agree that that is correct? That I can have two variables component and they can be equal to new of this child, new this child, new concrete component or new decorator, new ball or new box, whatever is the name that you use for the classes. Can we agree that this part is correct? The type of the variable, the type of the new polymorphic behavior, that is fine. Moreover, this one is one of these. That one, if I have this variable, the one that is represented by this relationship, just for my example, I am going to put this public. Or I can put a getter, a setter. But if I have this variable here in the class decorator, the box, can you agree that I can do the object dot this variable? I can put something there. I can put something there like this one equal to that. This. I have C1 that is a ball. I have C2 that is a box. They belong to the same family, but C2 is a box, and this particular member of the family have this relationship, this aggregation, this variable, and I can put something in that variable. Something like the ball. This line here is basically adding inside of the box the ball. Now, this is because I put the variable public. You can be thinking, now, I do not want this public. I want the variable private. If you have the variable private, you need a method public. A method public, like a method add, that receives as a parameter a component whatever is the name that you want to use. And inside of the method, the only thing that you do is this variable equal to what I receive as a parameter. And then what you can do instead of this is to call C2. C2, remember, is a box. The method that is public. And this is your parameter. The same add that you use with panels. This is your method add with panels. This method and this variable is something that you have in the class panel. Every time that you add another panel or a widget to one panel, another box or a ball in the box, it's polymorphic behavior. They are family. Some members in the family are used part of the family, but others are part of the family and also have this relationship, the aggregation one. Now, this is inheritance. What is going to happen with this class and this class? And just to be clear, there are two. For the example, you can have 3, 4, 5, 1, and also this class can have family. I mean, this is inheritance. This one and this one, they are childs. They can take the place. They can replace the parent. You can have the class box is a decorator, but then you can have a box that is a circular box, or you can have something that is, okay, it's not a box, it's something else, a bag, whatever. They can be childs of box, and therefore they are going to behave in the same way. Question, these two guys, A and B, they can use this aggregation relationship there? They are going to inherit that relationship, yes or no? Can I create an object from this class here, bag? And I can do something like A dot add X, where X is a ball. That could be possible, yes or no? Exactly. It is possible, right? The child inherit everything from the parent, including the relationships. If the parent has this aggregation, all the child is going to have it. You do not need to put another diamond here with another connection. No, inheritance. Whatever the parent has, the child is going to have also. So I can create another class, a bag, this one. And that one can use the method add. And that one is going to behave exactly in the same way that box behaved before. That is the reason, because the graphical user interfaces in Java, you can have panels. You have JPanel. But also you have other options. You have panels with different layers. You have panels with tabs and so on. You have panel panel have childs, and all the childs can do exactly the same that panel. Well, the name of the classes are different, but that is the idea. This is the key element, this inheritance and disaggregation, the complete source code. Let's review. Full source code for the pattern. And I put the diagram here in the corner. Number one, we need this class here, the parent for all the family. The parent for all the family, that guy, I do not want to create objects from that class. The only reason because I have that class is because I need a parent for everything. And you're going to notice this in several examples with object-oriented programming. When you need a parent, usually you do not want to create objects from the parent. You want the object from the childs. They want to have something to do. The parent can be an interface or an abstract class. And the only thing that I am going to do with that one is to define one method that is going to be in all the members in the family. In the original pattern, the method is operation. Tell me, can I make this one an interface instead of an abstract class? Yes or no? Use this source code. Can I change abstract class for interface in Java? Yes. Why? Because I do not have variables and I do not have bodies in the method. It's an empty method, a method without body, no variables. Java, the recommendation, this guy is a candidate for an interface, whatever. In the original pattern, if you read the implementation is an abstract class, I just put the abstract class there. Both are abstract. Remember, the big difference, at least in Java, is with the attributes and whether or not you need some method with bodies. In this case, in Java, a perfect candidate for an interface. Anyway, an interface that is the common parent. Very simple. Which is the name of this method if we think about widgets and panels in Java? That method operation, what is the method that is defined in the parent and that exists in any of the widgets and also in the panels? Well, add is going to exist in the panel in order to add new elements, but we do not have an add in the JBottom, right? We do not have an add in the widget, so it's a different one. Which is the method that this operation is not add that exists in all the family, both widgets and panels? You use this for your Pac-Man and your assignment. Something that both the panels and the widgets do. That is the method. Do you remember that in order to draw your Pac-Man and your things, you overload the method paint component in a panel? Labels, JBottom, text area, text field, all the widgets have a method paint component. The method that draw the shape of the label or the text area, the rectangle in white, it's a method paint component. That is this one. Remember, the patterns give you the template. In the template, you need a method in all the family. What is the name for that method? Depending on the problem that you're solving. For the graphical user interfaces in Java, the problem that we are solving is to draw things on the screen, paint component. For other problems, you can choose a different name. For the template, remember operation. Okay, done. The panel. Next. The panel have two kits. This one. That one is the child that do not have anything. That is the child that is like the ball, You cannot put anything inside. That one is like the OK widget, or like the text area in which you write. This class is the class that is going to define those elements that cannot have anything inside. Those elements that are the main thing, the important thing that you want to decorate. The elements that the only thing that they have is they inherit from the common parent. That's it. And because they inherit from the common parent, they are going to override the method operation. What do you put inside? Whatever you want. In the case of this guy and this guy, the instruction to draw them on the screen. And I am going to show you the example later. In the case of my ball, maybe the method to draw the ball. In this example, I am not drawing anything yet. Use a message. I am going to print this message just for you to notice what happened later. So operation, override, put whatever you need there. Nothing fancy here. Next, the other child, the important one. This is the one that is special. This is the one that can have things inside. This is the box. This is the panel. For that one, two things. We need this inheritance. We need that inheritance in order to keep polymorphic behavior. We need to make this one and the previous one brothers, sisters, so they can work together. They can replace each other. But also, we need this diamond here. And as we did before, that one is the diamond, a global variable. A global variable from the same class that I am inheriting. And as we did before, if I have the variable, I need a public method to receive a value that I can store in that variable. Usually in Java, a setter, set and the name of the variable, set component. The method that we're going to use most is add. Just because add is the one that you use with the graphical user interface. What I want to be clear here is a setter, receive a parameter, the parameter is stored in the variable. Whether you name the method set component like this or add, do not make any difference. It's just the name that you want to use. Add, set component, same idea, your preference. Well, these two things are the things that make this guy special. The other thing is, just because he's inheriting from the common parent, this guy also needs to do an override of the method operation. Now, something very, very important here. Did you notice what is happening? The previous one, here inside, these guys are free to do whatever they want. But this one, what is happening there? And what that is important, this line. If I am a box and someone put inside of this box a ball, or if I am a panel and someone put inside of this panel an OK button, someone is going to call from this guy. Remember, we're here with the decorator. Someone is going to call for the panel or for the box, the method operation, the method paint component. What is going to happen when that someone called the paint, someone called the operation? Here, did you notice that the panel, the box, is going to call the same method in whatever variable this one have inside? I received the call, but if I have something inside, if I have a connection with another panel or with a widget, or if I am a box and I have inside another box or a ball, I am going to call that operation in that object that is inside of me. When you do a graphical user interface in Java, do you remember that you create several panels and several widgets and you put them inside of another panel, and at the end, everything go inside of the frame, and the only one that you ask to be paint or make visible is the frame? That frame, that panels, have a method like this. The panel is responsible for calling exactly the same method for all the things that are inside. And if that one have more inside, it's a cascade of callings. So you only ask the external one to do something, but that one is going to ask for exactly the same to everything inside. And at the end, in the graphical user interfaces in Java, what you have is all your elements on the screen. All of them are there. It is not your responsibility to draw them. You only draw the external one. And that is this method. Okay.
Just a quick clarification question. When it's add component instead of set component, that means that the protected component variable would be a list of some kind, a list of components, right?
Well, the method can be add, even if we have only one, but you are right. In the graphical user interfaces in Java, what happens is inside of a panel, you can have not only another one, but maybe several. And what is going to happen is this guy here, instead of being only one variable, is going to become a data structure. In particular, yes, it's going to become a linked list. And therefore, yes, the add is the add for that linked list. Mm-hmm.
Okay, thank you.
Welcome. So, kind of simple. The last thing, this is the parent. And we need the child for the parent. The child for the parent, remember, these childs are going to inherit all of this. These guys are going to have all of these elements. I do not have here variables. However, I am inheriting this one and the methods. This guy, this child inherit from this class, which imply that I am also inheriting from the common parent. Remember, inheritance? The only thing that I am going to do in the same way that all the members of the family is to override the operation method. Now, my responsibility as a child of the class, my only responsibility is be sure that the method operation in the parent is executed. Do we understand what happened with this super operation? Do we understand what is super in Java and why super is here, the first line of this method? What is going to happen with that super operation? The parent. Good. Can you agree with me that this line here is going to call and make all these instructions to run? Every single time in these childs that you call operation, that operation, this one, is going to call this method, and this method is the one in the parent, and the one in the parent is going to call the operation of whatever have inside. And whatever have inside could be one of these or one equal to him. And later, I call the super, I call the operation in the parent, and then I can do whatever I want. Whatever I want, draw something, call something else, any action, modify variables, whatever. Whatever you need to do, this is your space. The only thing that I am doing is to print something. This and this, the important elements in the class. The only thing that are mandatory for me to do beside any other thing that I need to implement. This is this guy. And if I want to review the other guy, this one, it's going to be more or less the same. Extend, call the super, whatever else, including another method and call the method, more variables if you want, that is up to the problem that you are solving. The only thing mandatory for the pattern, this and this. Everything else, solve the problem that you are solving. Do whatever you need to do. I have this printing here, decorator B. I have this printing here, decorator A. And I have this printing here, component. So I have only 3 prints in the full program. When I put all these together in a main, do we understand what is happening with the main? One, two, 3 objects. One is from this class, like the ball. This is the equivalent to the ball. 2 from these classes, like different boxes. 1 box and 1 bag or whatever. And then connect them inside of the first decorator, like inside of the first box, I put the ball. So I am inserting this one here. And then this one, the one with those 2, is going to be inside of the second one. So it's like the box with the ball is going to be inside of the bag, if those are the names that I want to use. And the only thing that I do is to call operation, lowercase, for the external one. The only thing that I do is to call operation there. And if you remember, the only thing that should happen here is operation in this one. That one is a decorator B. That should print something related to decorator B. There is a print about decorator B. So that print, that message should happen. And it's going to happen because I am calling this method. However, as we remember, according with the pattern, this one, the bag, is going to call the same method in the box. And that one is going to print another message. And in our example, it was something like print decorator A or something. And that one is going to call the same operator, the same operation in the original object. And that one is going to print something else. So even though I am calling operation only one time, this program is going to print, hopefully, 3 things on the screen. 2 about the decorators, these guys, and at the end, something about the original element. That is the output if you run the program. The component, the decorator. One question for you. Why the first line is printing component? Because according with this output, looks like the first one that prints something was the ball, and then the box, and at the end, the bag. I call this method called this method, and that one called the ball. And the first one that prints something was the one inside. Why? Because of the super. Do you remember that the first thing that you do was to call the super before the printing? So do you remember, if you review the source code, that when this guy is calling this one, before printing something, is calling the super, and the super is going to call the component that you have inside? And this one is doing exactly the same, calling first the super, and that one is going to call the method in the component inside. That is the first line. And then you do the print, this print, and then you return. You do the other print, and then you return. You do the final print. When you draw your screen in Java, your graphical user interface, the first thing that you put there, the widgets, and then your panels with the widgets, the frame at the end. Decorator. Any question? Perfect, right? Okay. Now, the big question that I have is, when do we use this pattern? Because I just show you that you are using this pattern for the graphical user interfaces in Java, but what other things we can do with this pattern? When we use this pattern? This pattern is a replacement for inheritance. Think about it. If I ask you to create a class person, and then I ask you to create a class student, or a class professor, the first thing that you do, just because it's a classical example in your 110 classes, is, okay, if I have a person and a student and professor, and we know that the student and professor are basically persons, but with something else, inheritance. Your concept of inheritance is, we have a class, and this class has something else, something extra that the parent. Inheritance. Option number 2, decoration. I have this guy that is like the person, and I would like to have the same guy, but with this mask, whatever is that. Or I would like to have the same guy, but with this hat, or a combination of a particular elements. Option number 1, you can be thinking like, this is the class parent, and we can create this child and this other child. Or we can create this and this as elements that we can use to decorate the original. Two different approaches, we could do the same. There is one scenario in which inheritance is going to fail. What if I want these guys, but also I want one that have the mask and the other elements? Option number one, you can be thinking here, inheritance, and I can have the same guy, and I can put the same mask, and I can put the same hat, and the triangle. Another element of the family. This is a good idea or a bad idea? This one here. And hopefully you agree with me, it's a bad idea. Yes. Do you remember this concept? Do not repeat. And if I have this idea of doing inheritance again, you know what? I have the mask here, whatever that is, methods or variables, whatever, but I have that there. And I am going to have the same thing here, same element in two classes, and same elements in two classes. Very bad idea. Really a bad idea. Now, the other option is, okay, I cannot create a child like this because it's not going to be dry. I am going to be repeating the mask and the other elements. What about, well, if what you want is something that have this element and also have this element, I can create this guy as a child inheritance from the other two. Well, problem number one, if you're programming with Java, you cannot do this. Multiple inheritance in Java, you cannot do it. C++, you can do the multiple inheritance in C++. Did we notice the problem even if we are using a language that allows multiple inheritance? Do you remember this diamond? Hopefully you reviewed this, right? Multiple inheritance. The worst thing that could happen is you have the diamond, and the problem with the diamond is this guy have two bodies. Because yes, you're inheriting the mask and you're inheriting the hat, but the body, you have two. And that is a big problem. The diamond problem. In fact, that is the name, the diamond problem, if you review that with multiple inheritance. So multiple inheritance is not my solution. When you have a scenario like this, instead of inheritance from the beginning, this is asking you for decoration. This is asking you for doing the body is like the ball or like the widgets. The body is this element that cannot have anything inside, that cannot be a decoration to others, the core. But then the mask is one of the decorations. I put the full picture here, but the decoration is used, the mask, the additional things. And I can have another one. This and this can be the second decoration. So in real time, you can create one of these, like the ball. And if you want to add this, you add it. And if you want to add this, you add it. If you want to add both, you can put both or more. In general, if you have a problem and that problem requires multiple inheritance, is asking for decoration. Number two, in general, if you are planning to use polymorphism, if you need polymorphic behavior, like in the professor and student, If you're thinking like a professor can be a student or a student can be a professor, if you're thinking about using polymorphism, you need inheritance. If you are not thinking about using polymorphism, most of the time, it's better to do decoration. Again, the only thing that decoration cannot replace is polymorphic behavior. If you do not need polymorphic behavior, probably it is better to decorate real time, runtime, instead of having all these classes with inheritance in compilation time. Good. Okay, now let's program this. I want the guy and I want the decorations. If I ask you to program this, you have the idea, you have the knowledge of which are the core element, which are the decorations, you have the class diagram, and you know how to transform the class diagram to source code. Moreover, hopefully you can notice that now these lines are not solid, so something happened here in the implementation in Java. I still have the diamond, and now instead of operation, I am going to have this do something, do something, do something, do something, do something. The method do something is now the operation of the family. Moreover, add, instead of set component, I move to the idea of adding, add. With that, you have the full idea of the source code. Let's check. Source code. With this, do we understand what is happening in this main? Object number one, basic companion. Object number one from this class. Yeah, go ahead. No? Okay. Object number one from this class, no decoration at all. And I call the method do something. Object number one, the original, the small person, call the method, and the only thing that I have is a hello. Some asterisks, so just to separate. Example number two, the same object, basic companion, the same guy, but now I am going to create also a decorator of this class, and I am going to put them together. The small original one inside of the second one, adding to the original one the decoration of this thing and this thing, whatever that means. A decoration and an original one. And I am going to call do something. Just like I did before. Do something. And now my result is whatever the original do plus whatever is the decoration. In this example, I am using text, just printing things. We can work with the graphics in the next one. I call the operation, and what I get is something different than I had before, just because this line here and this decoration there. Another example. One decoration, two decorations, and the original one. And I connect the original one with the two decorations. Oh, well, one decoration and I put the original one inside, and then the other decoration, and I put that decoration to everything that I had before. This one, inside of this one, inside of the other. Two decorations and the original one. And I call do something. And now I have the original one plus one decoration plus the second decoration. Again, just because the add and everything happen automatically. The classes to achieve this. At this moment, you remember the pattern. At this moment, you remember what we're going to do. This was the main using the pattern. In the original pattern, number one, we need a parent for everything. A parent for everything. An interface, the original parent. Now I am naming that companion. The names can be whatever I choose. The structure is important. The parent for everything, companion. And now it's an interface. You told me before that I can use interfaces. And that interface, the only thing that have is the definition of the method that is going to be in the full family. Do something, as I show you with the main. Done. The parent for everything. The child's. Basic companion is the first child. Basic companion. The small body. Implement the parent is an interface, is going to be implement. Override the method. Override the method, and the only thing that you need to put inside is whatever you want that object to do. And as you noticed before, this is the one printing this hello. That is the body, that is the original one. Hello, nothing else. Check. The other child. The other child is the decorator, the parent for the decorators. It's also implement the common parent. Therefore, it also override the method. And this one is the important one. The one that is going to have not only the inheritance for the parent, but a variable from the parent. Variables, private, protected. You put here your knowledge of Java. The recommendation, not public, you know that, encapsulation. Protected, yeah, so the family can use it. The method add or set component. The parameter is the one that we're going to put inside of the variable that we have in the class. The override of the method, do something, and the only thing that this guy do is to call the do something in the object that we have here. Call the do something for the objects that are going to be inside. This is used from the pattern. This one do not have anything related with the problem that we are solving. There is no print here. Use the pattern, the template, identical to what I showed you before. Different names, but we already reviewed this, or this, or this. The three elements there. The important ones, the childs from that class. The decorator for the helper. The decorator for the helper, as we did before, we need to override the method. We need to call the super. And after you call the super, do whatever you want. In this scenario, printing something. What about the other? The same. The effective one, inheritance, override the method, call the super, do whatever you want. The message. When you run this, original, this guy, decorations for, you know, help or kind of the mask and the other things. Using text. Decorator pattern, clear. Questions? Easy. Okay, next step, Professor. You are showing us pictures, but the source code is just printing text. What if we really want to work with pictures? What if we want to put not only these classes that represent these elements like abstract instance, but I really want to draw this guy or this one, even the mask, I want to draw that in an application. Help me. What do we need if we want to use this pattern, but we want to create not printing hello, but having this guy, the white one, on the screen? Moreover, not only printing hello and I am here to help you, but printing on the screen this guy with the yellow hat and everything else. What do we need to do? We can start with the class diagram, right? I mean, we need more source code, but let's think about the diagram. We need a panel. Can you agree with me that if we want to draw something, the first thing that you need is a class, and that class should inherit from panel. And that class is going to have a name, whatever, but that one should inherit from panel. And inside of that panel, you can use instructions for drawing things. You use that for the Pac-Man, remember? In your assignment, you draw things in a panel. Do we need to connect this class X or maybe this class panel with the pattern? And if so, how? Which class do you think we need to connect? Which one? Well, that is very, very important. Companion inherit from panel. I will not recommend you that, because something that we need to review later is it's very, very important to keep separated the graphical user interface and the functionality of the software. The patterns, these patterns are there for functionality. They are going to do the draw, but the draw is going to happen in a different place. Let's have this class X being the one showing you the pictures, the one in which you are going to draw, and let's keep the pattern in a separate place. So this class X is going to be the one inheriting from panel, and what we're going to have is a connection between that one and companion, instead of doing inheritance in companion. So the graphical user interface, the classes that I have in red, and my classes in yellow, the pattern, separate from the graphical user interface. Now, the connection between X and companion, as you mentioned in the chat, those two are the ones that need to be connected, because instead of the inheritance here, I have the inheritance in the class X. Now I connect the X with companion. Tell me, which connection should I use between X and companion? Aggregation, composition, association, inheritance. What do you recommend? This is the graphical user interface. And these are the methods that I need to use to draw things. What do you think is going to happen between this class and this one? This one is the one with the knowledge about the drawing, and this one is the one that need that one to do draws. Association, I agree with that. Association, and the arrowhead is going to point to companion, or is going to point to X? Which one is using which one? Because association is using, right? companion using X or X using companion. To companion, the arrow is going to point to companion, something like this. And hopefully you agree with that one, X use companion. Hopefully everyone agree with that, but yes, that is the idea. I am going to have this class X. We're going to use a different name, don't worry. But I am going to have that class. That class is going to be a panel. It's going to inherit from panel. And that class is going to be using companion. And using companion to create all these different guys. What else do we need? Hopefully you agree with me that we need a frame. We need a frame because we need to put that panel inside of a frame. In fact, we need a class. I am going to call the class main, but that one is going to have my method main, that by the way is static. And this class, the one that have the main, could be a good idea to inherit from JFrame. And that one could be a good idea that one uses a class X, a panel. Maybe you're going to want to use there a diamond, so have a panel if you want. And this should be the final class diagram for moving our program from a text-based interface to something graphics. Homework. Review the source code, the one that is working with text. Next lecture, I want to finish with the graphical version. Good? Any question, guys? Okay. See you next lecture. Thank you.